We now want to talk about the applications programmers interface to Fusion 360. You have interacted with Fusion 360 graphical library and application framework thus far using the graphical user interface. Usually, GUI tools are encapsulated in well-arranged icons that lead you into filling forms and supply other useful information. That way, you make your sketches using primitives such as lines, rectangles, circles, modify these things by applying dimensions, constraints, until you obtain actionable sketches that could be further processed. There are so many things. You sometimes can extend a line. Sometimes you can make a line to be doubled, and there are so many things you can do. From these sketches, you continue to 3D objects that were obtained from extrude, revolve, loft, sweep, etc. The latter also requires you to specify things like extent. Okay, you want to extrude. How far do you want the extrusion to go? Do you want the extrusion to go on one side? Do you want it to go on both sides? Do you want it to be symmetric? And or do you want it to reach an object or be equal to another object? You do that with revolve, with loft, sweep, and so you also get profiles. For instance, if you want to sweep, you have to have a profile that is at a perpendicular angle to the path that you are sweeping through. And then you can now, once that path is defined, you can get your sweep. And that way you create things like the pipe inside a solid for cooling. You can use that to do other things like the reinforcement rods that you see in my example of the bench that has reinforced concrete beams. You see how the sweeps were used to create the reinforcement concrete rod of any thickness that you can have. So all these things are done using the graphical user interface. So the graphical user interface is the view that most people will ever see on the Fusion 360 and many drawing packages. But we are going to move a step further. We are going to go to the application programmers interface called API. The API is another window into the same graphical user interface. Whether you are using graphical user interface or you are using API, you are addressing the same graphical library. You are just having just another view of the same thing. In the one case, you are manually picking the facilities one by one and implementing them until you get your design. In the application programmers interface, you are writing a program, and your program will have so many steps, and your program will go to the same library and pick the things you need to give you a design. The beautiful thing about the application interface is that you are able to do all of that, and you can use the application programmers interface to create drawings, and those drawings can now come out, and you can continue working on those drawings using the GUI. There is nothing stopping you from taking the product of the application programmers interface and continue working on them using the same GUI. So you can mix both. So just know that whether you use the API or you use the GUI, you are still referencing the same applications framework, that a graphical application framework that Fusion 360 presents can be reached from those two ends, and the two can be mixed. GUI before API. The GUI is a prerequisite to working in any other way with the Fusion 360 environment. You need to master simple drawings and solid models and understand how the graphical environment receives commands. So there is no need going to the API if you do not have some basic skills in the GUI at first. Usually there's a variety of ways this can happen, but you need to master simple drawings and solid models and understanding how the graphical environment receives commands. Last week, for instance, we went through the creation of a simple heat exchanger in a cooling system using the GUI. Today, I'm going to take you through the same thing using the API. I chose this particular thing because it's a very simple example. It has maybe a simple rectangular extrusion for the body. And then after that, you have a cut through that extrusion to make the hole, and another sweep to actually put the pipes inside that would admit cooling liquid, and then you have other extrusions at the back to give you your fence. So those are the kinds of things that you have in this particular thing, and they are simple enough, and they will be used to advantage in helping us begin to see how the API works. The API involves a lot of things, but you just start with simple things and you can build up gradually. And to the question, which one is better, GUI or API? None is better. You know how to use the tool, and then you will know which one is best thing to do depending on your circumstances. There are people who will never need API, but in a university where at the end of the day you are going to be simulating use for your mechanical courses, which are the real design courses. Many times the university education, you can have your university education without even knowing what the design courses are. The design courses in your program are the courses that have mechanics of knowledge of fluid mechanics, strength of materials, mechanics of materials, thermodynamics. All of those things are design courses. But the beautiful thing about the graphics course is that you can now use the graphics course to actually now make the designs come out. Those are the design courses, and it is there you are going to use the equations that you obtain to do your simulation, which is essentially using powerful numerical methods to solve difficult equations, like finite element analysis, like computational fluid mechanics. And the beautiful thing is that your Fusion 360, your ANSYS and Solid Edge, SolidWorks, all those ones are built fundamentally with all your mechanics courses in mind. So they know all your equations already. So there is nothing in your courses that are, the people who design these are really top professors in best universities in the world, even though they may not even be staff of Autodesk, but they were the people that actually wrote the code. So there's nothing you are learning in the university that is not already implemented inside it. But it's only those who learn through the university that can have enough confidence and understanding to use those things. And your API effort is to give you the powerful skill to be able to go that far. People who are learning Fusion 360 on the web and they are not studying engineering will not be able to go as far as we are going to take you now. So there is a need for a lot of things. So I would list the things you need to know. You need to be skilled in to be able to come into the API. But I'm going to do it in a gentle way. The heat exchanger. This is an example of a design that can be the beginning of analysis using numerical methods, such as finite element analysis, computational fluid dynamics, and so on. When you go to analytical simulation of parts and components, you are able to create a number of related parts with small differences between them. When you are simulating, you are optimizing. You are trying to say, okay, look, if I design it like this, compared to if I design it like that, which one is better? For instance, if you have your heat exchanger and maybe you made 10 pipes connected together to form the part. Somebody may say, well, look, maybe it would have been better if you would use 13. So if you want to change that drawing from 10 pipes to 13 pipes, are you going to go back again and start drawing afresh? That's going to, even though this is a simple drawing, it's going to be laborious. Suppose you need pipes with larger diameters. Suppose you want thicker fins with reduced number or thinner walls and so on. Those are the kinds of things that somebody who wants to do a simulation would face. It is quite possible that you want to analyze 50 heat exchanger scenarios. You make 50 new drawings, bearing in mind that all that may change from one to the other is just maybe the diameter of the pipe, maybe the size of the wall or the thickness of the wall, or maybe the number of fins. Do you do new drawings each time? If you want to look at 50 different kinds of drawings, you want to analyze 50 heat exchanger scenarios, are you going to draw 50 new ones? Even when it is a simple drawing, you now begin to draw 50, you can see how laborious and tedious it becomes. What if you want to look at 500? By that time, you can see that the method of using manual way to be changing that becomes almost impossible. Even if the drawing processes are simple, tedium and fatigue will enter, and you wish for a better system. Vision 360 and other CAD packages anticipate these issues and allow you to parameterize your drawing. This parameterization can be done in the GUI to some extent, and we will introduce the parameterization on the GUI later on. But I am so eager to make sure that you know how to do the API, and I know it's going to take a lot more time that I want to start with that. We can come back again and look at the parameterization in the GUI before the end of the course as time permits. Now, API programming it is. So prerequisites. You must have your full Vision 360 installation. In this case, you will need your Visual Studio Code and your Python. That is one of the reasons why this is one of the things that guided my emphasis when I was teaching you Python last time. So I knew I was doing it because I knew what we would need in the course that would follow. I guess I may be asked to teach the course, and I'm teaching the course now. So I'm happy that you are prepared to some extent in that. The Vision 360 installation is one of the things you need. Your Visual Studio Code. And so those of you who are wondering whether you must use Visual Studio Code to do Python, you don't need to. But if you want to do Python now with Vision 360, the only editor recognized is the Visual Studio Code. If you are using any other editor, you cannot do what we are saying. So Visual Studio Code is now compulsory. It's not optional. So we are not saying it is the best. There may be better environment, but that environment is not recognized by the Vision 360. The Vision 360 people just went with Visual Studio Code. They don't care whatever else they want to do. It's not their business. And you will see that if you don't use Visual Studio Code, the iterations in writing your code, checking it and going back, moving it, you will not be able to do that if you do not use Visual Studio Code. You can also achieve the same results with C++. I think the C++ also uses Visual Studio Code. However, why do you want the harder way? My experience is that I make more progress teaching with easier programming languages, and they are often as robust as the older, harder ones. I used to teach C++ in this university, but I found out that it is much harder. Once I see C#, when I saw C# was easier than C++, and Python is even easier than C#. So I don't see why I should go to those other ones, because it's better for you to learn to develop and know more than to spend time worrying about simple things that make one language harder than the other. Now, you also need skills in the graphical user interface of Vision 360. So you need your Vision 360 installation, you need your Python installation, your Visual Studio Code that supports the Python environment. Then you need to have gotten some skills in using Vision 360 GUI. You can create a sketch using primitives, you can draw lines, you can you know how to chamfer, to fillet, and you know how to take that and extrude and loft, all those kind of things you need to. Then you also need skills in object-oriented programming. Last time, we learned to create objects such as students, specialized students, their methods, and internal data. We will rely on that experience. Programming. The key issue in programming with object-oriented Python is not that you will create your own objects. Instead, you will use the objects in the graphical application framework or graphic library framework, and supply values that will equate the way you provide information on your circle origin, diameter, sketch planes for drawing, forms you fill. You are going to be doing that, but you are going to be presented with objects, and it is in giving those objects values that you are doing the same thing, like giving. So you want to tell, you want to say a circle is 2 millimeters. There's going to be an object that you are going to equate to 2 millimeters that will now make that circle 2 millimeters and put it on your chosen sketch plane. How do you get a sketch plane? You are going to have an object presented to you that once you say, okay, that is my sketch plane, then it becomes your sketch plane and you can draw on it. It is the values you are supplying. So you need to understand how the objects work and how values can be given to them. An understanding of how object-oriented programming language works helps you to do this well. We will revisit some of this when it's necessary. If you have difficulties with your Python programming, I'm ready to give you some more of it. And I want a word of encouragement to those people who are still weak. If you find out that you dodged a lot of things in the Python class and you are therefore weak, don't now despair that, oh, I'm finished. You are not finished unless you want to be finished. You can actually use this to learn object-oriented programming, because I am going to encourage you. I'm going to give you code. I'm going to give you working code that you are going to modify, and you are going to assimilate and know some of these things by doing them. Many times, things that look difficult can be done by doing them. So, but if you have a difficulty and you are behind, then you must be ready to work hard. Now, you are not finished if you are ready to work hard. But if you have a weak background and you are lazy and you don't want to work, then you are finished. I agree with you, you are finished, and you are really, really finished. So, but if that is not your case, if you want to work and you want to learn and you want to ask questions, and when we give you solutions, you are going to spend the time to take enough proper care. I give you a code, you are going to read through the code, you are going to test the code, you are going to try to understand how the code works, and then make use of some of the ideas in your own program. You are not finished at all. You are just starting. Now you are at 200 level. I am excited to introduce to these skills at 200 level, because that is the time to know these things. If you know these things at 200 level, you are just going to spend the next 4 years at the university, and you are going to become strong, because you are going to be using this to make the other courses even come to benefit from the things you are doing. If you do things right, your graphical knowledge should be the centerpiece of all the other things you are learning. Not only so, you are also getting better at programming software using a modern language. And this might be your breadwinner for the rest of your life. So we are teaching the same Python that you can use for artificial intelligence. We are using it now in your graphics. There is nothing different from the way it thinks, whether you are using it for graphics or you are using it for artificial intelligence, you are using it for other things. So we are using this as an opportunity to develop your future. And I want your cooperation so that that future will be good for you. And as a teacher, as your teacher, I will be happy to see that you come through my course and your life becomes great as a result of it. It is my great joy when I see students that have gone through some of these courses and find out that no matter what happens in Nigeria, no matter whether Nigeria is going up or down, they themselves are going to do well. And if many of them are doing well, together they are going to make Nigeria actually do well too. So that is the reason why I spend a lot of time to make sure that these things happen to you. So let's see what I have next. Okay, this is like the end of my own program, my own slide. I will come again and do more later on. But let me see what the time is. It's already 4:47. What we are going to do now is that we are going to stay until 5:10. That is 23 minutes time. In 23 minutes time, we are going to continue. At that time, I'm going to give you a slide that I've prepared for this. That slide is already available for your downloads. If you have already downloaded it, maybe you've already watched it. But we will watch it together. It's a 14-minute slide. And when we finish watching that slide, it will guide the rest of my lecture today. So we start that 14-minute slide at 5:10 p.m. Thank you.